This is the second video for today. It's example number 8. So we're picking up from where we left off this morning. So notice that we had been doing multiplying and dividing, and now we're throwing in subtracting. The concept of the lessons from yesterday and today would be rational expression operations. So multiplying, dividing, adding, and subtracting. What do we do here? Well, first we have to recognize that this breaks into x plus 3 and x minus 3, and we have a 9 all by itself. Sometimes there's a little bit of confusion about they both have a 9. So when I look for the LCM, I'm looking at both. I need to have a single 9, an x plus 3, and an x minus 3. So off to the side, I'm going to write down a 9, x plus 3, and x minus 3. That's the LCM. It helps us determine what is the common denominator. You do not need a common denominator for multiplying and dividing expressions. You do need a common denominator, an LCM, for adding or subtracting. So I look on the left-hand side and I cover up. It has an x plus 3 and it has an x minus 3. It's missing a 9. So on this side, I'm going to attach a 9. Subtract 2. Now on the right side, the denominator has a 9, but it's missing an x plus 3 and an x minus 3. So I could write x plus 3 and x minus 3 because that's what it is. But if you recognize x plus 3 times x minus 3 is really the quantity x squared minus 9. Okay, here we go. 3 times 9 is 27. And then I have negative 2 times this quantity and negative 2 times this quantity. Notice a negative times a negative is a positive. When I combine like terms, I have negative 2x squared, and 18 plus 27 is a positive 45. Now I can't divide a negative 2 out here. And it's all over the quantity 9, x plus 3, and x minus 3. This is the simplified version of this expression. That is example number 9. Example number 9 is going back to division. So I'm going to grab a piece of paper and I am going to both factor the top and factor. Finding two numbers that multiply to equal negative 28 and combine to give you a negative 12. No. Hey, these two work if it's a negative 14 and a positive 2. Combines and multiplies. So x plus 2, x minus 14. Don't forget the 7 up front. Because it's different than 1, it needs to go underneath. And now I reduce the fraction when possible, and then push up 7x plus 2, and this reduces to 2. This is equivalent to this factored form. 14 times 2, again, is 28. Finding two numbers that multiply to give us 28 and combine to give us 11. 7 and 4 combine, both positive, and multiply. X plus 7 and x plus 4. Because it's different than a 1, 14 has to go underneath. Be careful when reducing this. I'll oftentimes see students say 2 here. No, it's 1/2. And both even, so I'm going to divide by 2 and divide by 2. And now push up. 2x plus 1, bottoms up, 7x plus 2. Well, how do we do this then? So I start the denominator. Is there any 2x plus 1s above? There is not. Is there any 7x plus 1s? So, although you see me cross them out, remember this really divides into 1. And the final simplified expression is this. Example number 10. Okay, notice that if I'm going to come off to the side here, and I factor this, this is x, 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 5, 5, 5. So I'm doing the difference of cubes here. 2 terms in the first, 3 terms in the second. This is always positive. I bring down 1x and 1, 5, and a subtraction sign for this problem. This sign is always opposite of the first. What fills in here? Well, I have 2 remaining x's, so that's x squared, 2 remaining 5's multiplied to give you 25, and this term can be found by multiplying the front and the back and forgetting about signs. X times 5 is 5x. On the bottom, I have x plus 3. Sometimes there's confusion. Do I need to flip these? You only have to flip when we're switching from division to multiplying. So we're going to keep it as is. I can see this is a difference of squares, so this breaks into x plus 5 and x minus 5. And then on top, I can see that both of these are divisible by 2, so I'm going to factor out a 2 and make sure I did it right, 2x plus 6. Now, this is an extra step you don't have to do, but when you multiply, you push the top together and you push the bottom together. So it looks like this. I'm going to throw that 2 in front. And you may be wondering, well, how do you go about with simplifying this? I just start with the bottom. Is there any x plus 3's on top? Oh, there is. So x plus 3 divided by x plus 3 is 1. Is there any x plus 5's? There's not, but there is an x minus 5. So my final answer is 2 times the quantity, x squared plus 5x plus 25, all divided by x plus 5. This is equivalent to this rational expression. Example number 11. Example number 11. Be careful, we're going to switch division into multiplying and flip the second fraction, which is taking the reciprocal of it. So I'm going to start by, I look here and I say, oh, okay, I can divide a 10 out of both of these, and I can take out a maximum of 1x. I'd be left with x plus 5. I always want to make sure I did this right. 10x squared plus 50x. Now on the bottom, if I factor this, what multiplies to equal negative 24 and combines to give you 5. 1 and 24, no. 2 and 12, no. 3 and 8. 3 and 8 do work if it's a negative 3 and a positive 8. Combines and multiplies. So x minus 3 and x plus 8. I don't have to worry about doing bottoms up because the leading coefficient is a 1. So this will replace this expression. Now division gets turned into multiplying, and this was on top, it now goes to the bottom. And this was on bottom, it goes to the top. Now before I write it on top, I'm going to factor it. 2 times positive 8 is a positive 16. What two numbers multiply to give us 16? Combined to give you 17, that'd be 1 and 16. Now be careful, leading coefficient is a 2, it needs to go on the bottom. This can't be reduced, so it pushes up, 2x plus 1, and this reduces to 8. So I'm going to replace this portion of the expression with this. You may be wondering, why are you putting it on top? It came from the bottom. Remember, division turns into multiplying with fractions, and the second fraction flips. So I'm going to push these two together. I have 10x, x plus 5, 2x plus 1, and x plus 8. I'm going to put this in front, 30x, x minus 3, and x plus 8. It doesn't matter where I start. I'm going to start with the x plus 8. So there's an x plus 8 on the top and on the bottom. And when you divide, it's going to equal 1. There's no x minus 3 on top. There's a single x on bottom, the single x on top. And when I reduce 10 over 30, 10 goes into itself once, and 10 goes into 30 3 times. That leaves us with the final answer of, and you wouldn't have to put a 1 out front. That's not necessary. This is our final answer. Now, in the past, I've seen a common mistake where students forget to put parentheses around the x minus 3, and so it looks like this. That would be wrong. This is not the same thing as this. Okay, it needs to have parentheses around it. Simplified expression. What do we do here? Well, this is a really common mistake because students assume that x squared plus 4 automatically is going to factor into x plus 2 and x minus 2. That is not the case. This has to be subtraction for that to happen. So this is kind of like a trick one. Well, what is the simplified form? This is one and this is another. It's a trick one. So when I go, what is the LCM? Well, it needs to have 1 x squared plus 4 and another x plus 4. Those are two separate things. So if I look at the left-hand side, I'm going to cover up x squared plus 4 down below, and I can see that this denominator is missing an x plus 4 to have a good common denominator. So over here, I need to attach the x plus 4. And likewise, this has an x plus 4, but it's missing the x squared plus 4. So attached to the negative 5 is an x squared plus 4. I'm going to distribute 2x plus 8, and take that negative sign with it, minus 5x squared minus 20. And now I'm going to combine like terms in the numerator. Negative 5x squared plus 2x minus 12. And that's all over x squared plus 4 and x plus 4. Sometimes students say, well, am I supposed to FOIL this out? No, leave it just in parentheses, just as is. You'll understand why when we learn how to graph rational equations. Leave it just as